Welcome back to Physics with Miyoshi here on YouTube. I want to talk to you today about vector addition, and today, this time, a little bit of vector addition. Notice the notation here. First of all, anytime you see this little arrow type thing on top, that means it's a vector, and a vector has both a tail and a head. And the way you add vectors is very simple. If you know that one vector is added to another vector, you just add them head and tail. So in a case like this, I have one unit. It doesn't matter what those units are, whether it's feet or inches or meters or centimeters or inches per second or newtons, whatever the unit might be, it's that unit. So if I have 1 unit east plus 3 units east, let's make this a little longer, then I would have just the same addition I would with any other scalars. I would do 1 plus 3, and this would be 4 units east, would be the resultant vector. And that's what we call the result, is the resultant vector. So A, B, and my C is just this resultant vector that is 4 units. Okay? So that would be this first one. And I'll just use U for units, and then I'll have 4 units east. So the second one we have here, second example, I have 4 units east plus 4 units west. In this case, now I have to be careful of my directions, but I have 4 units east. So there's my A, 4 units east. And then when I add my other, I'm just going to put this back here, so instead of putting it right on top, I'll put 4 units there to the west. So that's my B. And the resultant is whatever net I end up at. So in this case, I end up back where I started, so the resultant is 0 in this case, because I end up exactly where I started. So in this case, I have 0. And you can put 0 units. Obviously, you do not have to put any direction, since 0 doesn't have any magnitude and it doesn't have any direction. Okay? And the last one here that I want to show you on the vector addition is just any, well, it's not just any, it's 2 perpendicular vectors. I have 3 units east and 4 units north. So I would put a vector A, 3 units east, and then at its head I'd put the tail of my 4 units north. In this case, my resultant is going to be from the first tail to the last head, and you can do this with any number of vectors, even though we're only doing 2 at a time. And this is going to be my resultant vector C. Now in this case, we have to do a little bit of math. We have to remember that this is a perpendicular to each other. North and east are 90 degrees from each other. So I'm going to go ahead and find the magnitude of C by the Pythagorean Theorem. So C, if I don't put the little line on top of it, just means the magnitude of it. So C squared is A squared plus B squared by the Pythagorean Theorem. So in this case, I have 3 squared plus B, 4 squared. And then if I want to do that out, that's 9 plus 16 is 25. That's C squared. So if I want to find C, take the square root of that. Square root of 25 is 5. Now in math we'd say plus or minus 5, but here we know everything is positive. So it's going to be positive 5 is the magnitude. And then I have to find what they call the angle here. And I'm going to call the angle theta. Now theta is a little bit different. We have to know a little bit about trigonometry, but only a tiny, tiny bit. The trigonometry we need to know is that tangent is a ratio between the opposite leg, or the leg that's opposite or directly opposed to the angle, and the over the leg that's directly on the angle. So in this case, tangent of theta is 4/3. Okay, and if you want to find out what theta is, we do what's called the arctangent, which you determine by -1. Tangent of -1 of 4/3. That's the inverse function of tangent. That's going to give me theta. Okay, so tangent theta is the arctangent of 1.333, which is, if you do this on your calculator, theta ends up to be 53.1 degrees. So in this case here, our resultant vector is C is 5 units at 53.1 degrees north of east. Anytime you do this kind of addition of vectors where they're perpendicular to each other, you can always use the same way to find the angle, and you can use the Pythagorean Theorem like I just had up here to find the distance. So that's how you add vectors that at least are parallel. They're going the same direction. You can sometimes hear anti-parallel, which they're going the opposite directions, and then vectors that are perpendicular to each other. This is how you do them. Here's a few examples for you to try out. If I have A and B, 3 units north, 4 units north, what's going to be the resultant vector? 2 units east, 3 units east, what will be the resultant vector? So let's just put some numbers up here. 1, 2, 3, 4, 5. What will be the resultants of those? We'll find out next time on Physics with Miyoshi. Thank you, and we'll see you again.